Okay, now just to outline why it's so easy to solve an Ly equals B or Ux equals Y. Here's an Ly equals B. Here's a lower triangular matrix. Okay, right here. And here are, I could have written B1, B2, B3, but it's just any three numbers. These three numbers make up your B vector. So here's your L, here's your B vector, and of course this is the augmented matrix that represents this system. And we could write out the system, okay? If Y is Y1, Y2, Y3, we have to have -7 Y1 equals whatever this star is. 2y1 plus 4y2 equals whatever this star is. 7y1 plus 3y2 plus 5y3 equals whatever this star is. So, how do we solve that? Well, whatever this star is, we just divide it by -7 and we got our value of y1. Then we plug that value of y1 in here, so the only thing that's unknown is y2. So we just get a number here plus 4y2 equals this. We subtract the number we get when we plug y1 in here from this and divide by 4, and we've got y2. Very simple. Okay? And then we do the same thing. Knowing y1 and y2, we get numbers here. We just subtract them from both sides. Then we have 5y3 equals whatever number is left over, and we divide by 5, and we've got the value of y3. So we've got y1, y2, and y3, and we don't have to do anything at all tricky or anything at all involved or complex. It's just multiply and subtract and divide. And just a few operations. Now, it might not seem like just a few operations if this goes on for 20 rows and 20 columns. If L is a huge matrix and you got y1, y2, y3 down through y20, and you're trying to do it by hand, which would be crazy. I'm not going to ask you to do that. But you understand that that's probably a lot easier than trying to row reduce a 20 by 20 matrix. Okay? So that's the idea. And if you have an upper triangular matrix, well, then it's y3 that doesn't have, you have y3 equals something down here, then y2 plus y3 equals something, and sometimes y1, y2, y3 equals something here. And you start down here with this solution, and you keep back substituting. So what I outlined here is forward substitution. That's what you use. You start by getting y1, you move that forward down to here, and you get y2, and then you move those values down to here, you get y3. That's forward substitution. If it's an upper triangular matrix, you'd have backward substitution. And your book explains that. So that's just the idea.